In the last video, I showed you the basic functions we use to write parsers. In this video, I'm going to show how we build up from this basic level up to building a parser to parse integer numbers. So what we're going to try and parse is just things like 100 or minus 35 and so on. And then to convert these into an actual int value in Haskell. So we're going to break this down into some smaller parts. So the first thing we're going to do is to parse individual digits by writing a parser called parseDigit. So this is a parser which returns an int. So what does parseDigit do? Well, we use our basic parser for parsing a character. Then we use a function from the standard library called isDigit, which tells us whether or not a character is a digit, whether it's 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. If it is, then we return digit to int c, so that converts a character which represents a digit to an integer. Otherwise, we fail to parse. So let's load this in. And then we can test this little parser like this. So we parse digit. If we give it 1, then we'll get back the number 1, not the character 1, with no leftover input. If we give it an A, then we get back nothing, because it doesn't parse the digit. If we give it a 9, it'll give us back 9. Now we're going to use parseDigit to parse positive numbers by parsing one or more digits. So parse positive number. Well, if you remember from last time, we've already got a function which, given a parser, parses 0 or more. So to parse 1 or more, what we're going to do is parse the first digit. So we must always have at least one digit. And then parse 0 or more extra digits. 0 or more parse digit. And then we will have a list of digits. So what we need to do now is to write just a little function which is going to take a list of digits and turn that into an actual number. So we can do this with a fold left. So we're going to do a fold left, and then what we're going to do is take the number and the next digit. Then what we need to do is multiply the number by 10 and add on the digit. And then we'll start with the first digit and do this to the rest of the digits. So it's worth checking this works first. So let's just cut and paste this bit. And for the first digit was 1, and the remaining digits were 2, 3, then we did get 1, 2, 3. Why is this? Because we start with 1, we multiply it by 10, so we get 10, and add 2, so we get 12. And then we multiply it by 10 again to get 120, and add 3 to get 123. And then if we reload the file, we can test our parser to parse positive number 1, 2, 3, 4, and now it get us back no leftover input and the number 1, 2, 3, 4. If we try and put something at the start, it will fail to parse, and if we put something at the end, it will return that as leftover input. Now we want to be able to parse positive and negative numbers. So a negative number is just one that has a minus sign in front. So we're going to parse the sign as well. And for this one, I'm going to return +1 if there's no sign, and -1 if there is a sign. So we can use isChar, which is one we defined before. Say if there is a minus sign, then we return -1, or else we just return 1. And now to parse a number, let's just call it number. So parser of integers. So first we parse the sign, then we parse a positive number, and then we return the sign times the number. So now if we run the parser number on the input 123, we'll get back 123. If you run it on minus 123, we'll get back minus 123. And if there's any spaces, then we don't get back a successful parse. So that shows us that by breaking down the job of parsing numbers into parsing individual digits with the parse digit function, and then using our combinator to parse 0 or more things, to parse sequences of digits, and then using a little fold here to add up the sequences of digits into a number, and we can parse positive numbers. And then we can write a little thing using or else to parse the sign of the number. And then at the end, we parse the sign, parse the positive number, and return the sign times the positive number to parse the numbers.